first question asks us to sketch a free body diagram. The free body diagram consists a weight which is equals to mg, and it consists a friction force as it against the movement of the ball, and it has n against the ball. And the kinematic diagram of the object is, since it's rolling downwards of the ramp, it's equal to ma, this direction. To calculate the speed of the object, we use principle of work and energy to solve it. This equation represents the principle of work and energy. This equation is kinetic energy at point A, and this one is potential energy, and this one is kinetic energy at point B. As the object is at rest at point A, so the velocity is 0, and this is the mass of the object, which is 1 kg. This one is the gravity of the object, 9.81, and this one is the height of the object, which is 3.5 minus 1 meter. And this is the one that we want to solve, which is we want to find, which is VB. We solve it and we get this answer, which is 7. VB equals to 7 meter per second. In order to calculate the distance from the wall of the ramp at B to where the object strikes the ground, which is we put it as C, first we have to assume all the things that move to the right is positive. XC equals to XB plus VBC times TBC. XC we change it as D equals to 0 plus 7 times 4 over 5, which is this one. We find it using SOHCAHTOA, times TBC. D equals to 5.6 TBC. TBC remain unknown as we can find it at vertical. We assume all things that move upwards equals to positive. YC equals to YB plus VBY times TBC plus 1 over 2 acceleration of Y times TBC square. We solve it and we can find, we will get this equation, and we solve it using quadratic equation. After we solve the quadratic equation, we will get the two value of TBC, which is 0.1941 second and negative 1.050 second. We take the positive value and substitute at TBC, this one. After we substitute, we solve it and we got 1.087 meter as its distance. To find the speed, we use principle of work and energy to solve it. This equation represents the principle of work and energy. This is equation for kinetic energy at point B, and this one is potential energy, and this one is kinetic energy at point C. We obtain the velocity of the object at point B at previous question, and we use it, which is 7 millimeter per second. And this one is the kinetic energy, the potential energy, and this one is the kinetic energy, which is obtained VC, the things that we want to find, the speed at point C. We calculate it and we got the answer, which is 8.2837 millimeter per second. The question asks us to calculate the velocity of the object. First step is we use vertical motion to find VCY. The equation is VC square equals to VB square plus 2AC SCY minus SBY. VBY is 0 because we start at this point, which is it at rest, the velocity, and plus 2 times AC, which is acceleration, the gravitational acceleration, which is 9.81, and minus the position of the first position, which is 0, and this one is negative 1. And then we get the VCY values, which is 4.43 millimeter per second. Then we use the coefficient of restitution, which is E equals to VY2 minus VCY2 over VCY minus VY2. We have all the values except for VCY2. Then we can get VCY2 from this equation. VCY2 equals to 3.101 millimeter per second. Then we use the equation for the computation of linear momentum, which is M times VBX equals to M times VCX. We can cancel the mass since we have the same value of mass. So we found we get the VBX from the previous exercise. From the previous question, VCX equals to VBX, which is 7 millimeter per second. Then we can get the velocity of this one, which is VC2, using the magnitude of velocity. We solve it and we got 7.656 millimeter per second. Next question is to find this height. We use the vertical motion equation to solve this question. This is the equation of vertical motion, which is V to Y square equals to VCY square plus 2AC times S to Y minus SCY. V to Y square equals to 0, since the velocity at this point is 0, equals to VCY square. We obtain the VCY values from the previous work, plus 2 times AC, which is gravitational acceleration, which is 9.81, and S to Y, this one is where we want to find, which is H minus 0 at this position. 0 equal, we substitute the values after we solve it, and we got the answer, which is 0.49 meter.